Okay, I'm going to do a couple of problems from the review. I'm going to start with number one, which is do all the stuff with the function. First thing it says write in function in simplified form. So I'm going to do that right here. Um, you just need to factor the top. Hopefully everyone knows difference of two squares. I seem to not know myself. There you go. And the bottom is x minus 5, x minus 2, and x minus 3. Okay. At this point, you can do two things. I like to do the domain right away. So my domain is all x values such that x is not equal to 5, 2, and 3. And then we see what cancels. And the 3 one cancels. So that for sure is going to be a whole. The one that cancels a whole. And that's part D. So part D I'm going to write 3 comma something. We'll get to the rest of that later. And then I look and see if this can be simplified any further. It can't, so I can just write the simplified form of here. And x minus 5, x minus 2. I don't really care about f of x on this one because I give you a line for it, but if I tell you to write a rational function that has like a whole and a vertical asymptote, something like that, I do require the f of x. So we have that's the simplified form. Now we have to state the vertical and horizontal asymptotes. Vertical are what is left from the simplified form. So we get x is equal to 5 and x is equal to 2. It's the stuff that's not canceled in the denominator. We go back, we can actually look at the factored form. If you notice factored form, the power of x on top and the power of x on bottom match. When they match, we look at the ratio. The horizontal asymptote is y equals 2 because that is the ratio. To get the missing piece of the whole, all you have to do is take the 3 and plug it into the simplified form up here. If you plug it back into the original, you're going to get a 0 on top, which doesn't help you. So make sure you plug it into this. When it's all said and done, I believe 3 plus 4 is 7, times 2 is 14. So negative 14, negative 2, and 1 over negative 2 is 7. So 3 comma 7 is your whole. We're almost there. We have to sketch the graph and tell me the range. So I'm going to sketch the graph from memory. I do not have my calculator on me right now, so we're going to see what we can do here. Okay, I know there's a vertical asymptote at 2 and at 5. So put those down first before you even graph it. And we have a horizontal one at 2. And remember, horizontal asymptotes can be crossed in the middle. It's just the end behavior that they can't be. What else do we have? I have a hole. My hole is at 3, 7. 1, 2, 4, 5, 6, 7. The hole's up here somewhere. And I believe the graph looks something like this. I'll do the graph in green. Coming down through here, and then like that, or something like that. Coming back up from the top and going off forever. And then coming from the bottom and going off forever there. So that is what I need. I need the discontinuities, which are the horizontal and vertical asymptotes. I need the hole, and I need the graph. The range. In this one, if you look at the range, it's all y values. Well, I'm not going to say anything actually yet. We're looking for the y values. The only thing it can't be are the horizontal asymptotes and the holes. However, this graph crosses the horizontal asymptote, so we're counting it. So that's not a restriction. And the hole, even though there's a hole here, if you look right next to it, there's a line going through that same y value. So where 7 does not exist in the y, here's y equals 7, if I draw a line across, doesn't exist there, it does exist here. So that means that this graph actually has a range of all real values because it's crossing the horizontal asymptote and it has another spot where the hole is being covered. So the range is all real values. And that is one of those complete problems for simplifying a function and getting all the important pieces and graphing. All right, let's do number Let's do an adding and subtracting one. I think I wanted to do number 10 or 11. 11 is good because there's 3 parts, and it actually incorporates everything we've been talking about. First off, this one turns into x over x minus 3x plus 3. Now, I want x minus 3 or x plus 3 for my bottom. Since this has a minus sign, I can flip it, but in order to flip this, I have to take a negative 1 out. Okay, and when I take a negative 1 out, I like to put it where that sign is, in front. It's just easier to remember. So, this now becomes a minus sign because I took a negative 1 out, and when I took the negative 1 out, this turned into x minus 3. I flipped it around. I do not, however, need to take a negative out for the next part because you could just flip that around. X plus 3 is the same thing as 3 plus x. So now it's simplified into an easier form that we can work with. We can see what we need for our LCD. We just need an x minus 3 and an x plus 3, which means I need to multiply this by x plus 3 over x plus 3, and this one by x minus 3 over x minus 3. And we know our bottom. Let's deal with the top now. The top is x minus, and again, distribute the minuses, minus 2. Okay, x plus 3, x minus 3. So when you distribute the minuses, you basically get x minus 3 minus 2x plus 6. And I'm just going to deal with that right now. X minus x, those go away. Minus 3 plus 6 is a plus 3. You get negative 2x plus 3 all over x plus 3 and x minus 3. You can't do anything else with the top. If you want, I guess you could take a negative out, but I'm okay with this. This is all I want. It's an expression, no f of x. You're good there. Let's do complex fractions. Let's do number 12. I believe 13 was actually on an old worksheet. So you have to simplify both top and bottom. Here's the bottom. Let's do that first. This turns into 3 over 3 plus x over 3. 1 you just turn into 3 over 3. You need a common denominator. So basically this turns into, I'm going to call it x plus 3 over 3. That's the bottom. Top, I need an x on the bottom, so I have to multiply the top and bottom by x. So this turns into x squared over x minus 9 over x. So this basically turns into x squared minus 9 over x. So that's the top. Remember, you take the top, you multiply by the flipped bottom. So I'm going to do x squared minus 9 over x times the flipped bottom, which is 3 over x plus 3. I'm not done, though, because I can factor that now. And so we got x plus 3, x minus 3 times 3 all over x and x plus 3. These cancel, so your final answer is 3 times x minus 3 all over x. And that is how you do a complex fraction. Do the bottom or top first, simplify them all the way so that they're just fractions, and then flip the bottom one and flip it up to the top one and multiply it to the top one. So the top one should not be flipped ever. It's always the bottom one that's flipped. All right, let's do one of these. I don't care. Let's pick number 14. My LCD here is x plus 4x minus 4. So if that's my LCD for solving ones with an equal sign, you just multiply the tops because we're not trying to get a common denominator to combine them. We're trying to get rid of the bottoms of these fractions. This turns into x plus 4, x minus 4. This is 2 times x plus 4 and x minus 4. And when everything that we look at cancels, these cancel with these. So we're left with 3. On this side of the equal sign, we get 2x plus 4 equals, the x plus 4's cancel. We're left with x minus 4 minus 3. So we are left with 2x plus 8 is equal to x minus 7. So we get x is equal to minus 7 minus 8 is negative 15. I'm ready 5. Sorry, the reason I'm pausing is I forgot to do the domain restrictions at the front end of this, but that's okay. So I got x is equal to negative 15, and I look at my domain, which I should have had from the beginning. Well, the domain restrictions are x can't be plus or minus 4. We look at our answer. That doesn't fit into that. I mean, that does fit into that. We're good. It's not one of our restrictions, so my final answer is negative 15. Okay? Just a little bit quick, just a few quick problems to look at for the review and how to do them. Just making sure I did this one correctly. I believe I did. I don't have the answers with me, so anyway, good luck studying. If you have any questions, please come in and ask for help tomorrow morning before the test.